Welcome to the Product Design and Development. This video is part of a series of videos that collectively will cover Product Design and Development course. So please make sure to check out the rest of the videos in this series. In this video, I'll talk about the difference between a design problem versus an analysis problem, and we'll go over some of the different types of design problems that we often deal with. Before we start, because we focus a lot on the problem, and eventually the goal is to create a product that solves that problem, it's important to think about what is causing the problem. Because a lot of time a problem is usually a symptom of an underlying macro problem, and sometimes a totally different issue. So when you think of a problem, you got to find the cause of the problem, and then look into the cause of that cause, then look into the cause of the cause of the cause, and so on. So if you think of this level 1, you get to level 2, 3, 4, and so on, until you get to the root cause of the problem and what is exactly causing the problem. The example that's given here in this paragraph is, hey, someone tells you people are not cleaning up after their dog. That's a problem. Or after their pet when they go on a walk. And they ask you to solve that problem. Or they ask you to create a product that solves that problem. So initial thought would be, hey, maybe people don't like to touch, the excrement of their pets. So maybe you think, hey, maybe if I design a better bag or a better scoop, this will solve the problem. But when you look into it, it says, hey, maybe a better scoop is not the solution, because the problem is maybe people who forget to bring their scoop or their bag, they leave it at home, so they just don't clean up after their pet. So now your product and your solution is totally changed. You are now designing maybe a leash that can incorporate the scoop in it or have some bags in it. So it's important to look at the cause of the problem. We'll get back to this a little bit later on in this course, and also address that when we are developing a product and a solution as the term project. Here's an example. When we want to talk about analysis versus design problem. Here's a question. Exam question. What size SAE grade 5 bolts should be used to fasten together two pieces of 1045 steel with this dimensions, and they're lapped over, and this is the load? I'll give you 5-10 seconds to think about it. You think, is this an analysis problem or is this a design problem? If you thought or said analysis problem, you would be correct. The design is already done for you. Somebody has already made the decision that, hey, this is the grade 5 bolt we're going to use. Maybe they're welded together. All they're asking for you is to figure out the size of the bolt they need. So one parameter that they need you to look into is the diameter of the bolt. It's very clear what the need is. Once you know which equation to use or how to incorporate normal stress and shear stress, you can understand the problem and hopefully generate a solution. If this is an exam problem, your professor probably has a key with one correct answer on that key, and that would be the answer to this problem. Now, when you look at very similar problem, and it says design a join to fasten together two pieces of steel, dimension, load, lapped over. Very similar. Even if it didn't tell us design a joint, you would know this is a design problem, because all it tells you is like fasten together. You don't know how. You don't know, is this permanent, or do you need to consider any temperature? All of those information will affect the decisions you make. So there are decisions involved with it, and with every decision comes a potential correct solution. Some solutions might be better than the others, but they're all correct solutions. So here are some questions that someone might ask. How do I connect them together? is that permanent, or do they need to be disassembled? Is this a high temperature, low temperature, or doesn't matter? Who's going to do this? Do you need a specific tools to be used? So all of those questions, again, the answer to all of these questions will lead you to multiple, I should have said, correct solutions. Again, some solution might be better, some might be a little bit less efficient. So here's kind of a summary of those two slides together. Analysis problems, very clear what they need. You just got to plug information into equations, use your knowledge of physics, mechanical engineering, material science, and generate a solution. There's not much decision involved with it, versus a design problem, you have some decisions to make. Maybe the problem is not well defined. You either have to ask whoever suggested that or your professor, or you got to make some assumptions along the way. You have a lot more flexibility, a lot more decisions to make, and as I mentioned, there's no correct answer to mention. When we talk about the problems maybe not well defined, sometimes the customer doesn't know what they need, and that's when, in earlier stages of a project, when you clarify a lot of needs with the customer, they might even realize some of the needs that they didn't think about. In addition to that, a good designer, with this kind of box down here, a good designer must develop a device or a product that has capabilities to kind of satisfy and meet some of the needs that are not even defined, or the customer might not even know them. So I know that kind of sounds a little bit crazy, but that's how reality of a lot of products are. If you're designing a toy, you never know what that kid is going to do with that toy. Put it in dirt, submerge it in water, drop it against the wall. Same with any other product. Look at the cell phone applications. Look at any agriculture machinery that you use, you design parts of that. You don't ever know what the customer is going to do with it, or what exactly their need might be. So as a good designer, you should always account for some of the unknown needs at that point. So the following slides, we're going to talk about different types of mechanical design problems. We're not going to talk about analysis problems anymore in this course. This is it. We just want to mention to clarify the difference. Everything else in this course is going to be a design problem, or a type of design problem. First one, you know it for sure, selection design. It involves you have some information given to you, then you got to make a decision. Based on that information, you go to a handbook, your manual, your standard, and you pick between available options that are available to you. Again, reading off the slide involves choosing one item or more from a list. The need is a little bit more clear than most design problems, but you still have some latitude, some flexibility what to choose based on the need. The example is kind of self-explanatory here. You need to select a bearing for a specific shaft. The torque dimension and stuff was given. You go to the handbook and you select the best option that you think is more efficient for your design. Another common type of design is known as configuration or packaging. Also, some refer to it as assembly design. And that's where all the components have been designed. You don't have to worry all the components. It's now time to put them together and how you arrange them next to each other. A good example of it would be the Mars rover Opportunity. That's kind of schematic is shown here in some pictures. All the components are designed: RAD, REM, IMU, web, SSPA, and so on. Your job is to kind of configure this together and put them together, and that becomes a packaging design. They gave you two specifications. RAD needs to be on top for sure, and then WB or web needs to be on the bottom. So you can start from the middle, kind of work towards top or bottom, or start from bottom to top, and so on. Again, you might generate multiple correct solution that satisfies any of those requirements. But again, this is a good example of configuration, packaging, or assembly design. The link I provided here, you can read more about the opportunity. I'm sure you know about it, but if you want to kind of follow the story a little bit more, or some numbers and some information presented here for you too. So feel free to pause it and go over the information. Another type of mechanical design is parametric design, and that's when some values are given to you and you can vary parameters, and everything that fits within that equation satisfies your solution. A good example here is like they needed a storage tank with this much volume of liquid as the capacity. Anything that fits in this curve that's shown here, a long skinny tank or a short large diameter tank, they both satisfy this. You got to look into other factors such as, hey, what are the space we have available? What are the materials that are available to us? What are how can we ship it? A lot of different factors might come in handy and be important in this decision making, or a lot of them the customer might leave it to you to make the best decision. Again, some parameters are given, but then you are responsible to figure out the rest and make the rest of the decisions. Original design is a lot of very common type of mechanical design problem, and that's when you create a new product, something that doesn't exist or has not been around. Not just product, could be assembly, could be a process, could be a component, something new. You're creating something new from scratch. As part of the process and designing that, you have selection design problems within it, you have configuration design within it, you have parametric design within it. So a lot of stuff that we talked about, the 1, 2, 3, will be within an original design and part of an original design. The product shown here is an air quality monitor, like a personal air quality monitor. And there are some initial concept sketches are shown here. You can look up this product and read more about it. It's a very cool product. Another type of mechanical design is variant design. When you have a product and you create different variations of it, again, an iPhone is a very good example of it, and you leave some of the decision to customer based on their need, which product they want to choose and what product they want to buy. A lot of consumer market products, vacuum cleaners, tools, cell phones, laptops, TVs, printers, a lot of electronics, all fall under variant design, when it's one product but a lot of different variations of it with a lot of ads on, and again, the customer picks based on their needs and requirements. And finally, redesign is another typical part of mechanical design problems. A lot of industrial projects, a lot of industrial senior design projects that we get in our program are redesigned. The company has a system assembly component that it's working, but it's not checking every box they needed. Or it worked at some point, but now the need has changed, so there's a reason for redesigning it. Something to also talk about in this context is mature design. Mature design is something that's been around forever without a major change. Bicycle is a good example of it. When you look at, for example, 1890 bicycle and today's bicycle, it's the same thing. Of course, the material has changed, the wheel diameter has changed, gear shift has changed, a lot of stuff like that, but the design concept's still the same. It's a frame on two wheels with a handle and a pedal, and that's pretty much it. So mature design might change, but again, the basics are the same, but you might want to improve the performance of it. Again, better understanding of human comfort now, so you might go design a better seat. Customers always looking for something new, something exciting, something more. That could be another reason. And also, material advancement, manufacturing method, lighter weights, a lot of those comes into play. Here's more examples of mature design. You can think of a lot more: pencils, pens, shoes, even cell phones. We're getting to that point that cell phones pretty much been around, since 2000. I shouldn't say forever, but For past 25, 30 years, the cell phones is pretty much the same, hasn't changed. The capabilities and improvement and material and durability, the battery life, a lot of that, but they haven't changed. But here are some more examples. So these 6 that we mentioned are typical types of mechanical design problems. And as we saw, something like original design or redesign might have other types of mechanical design within it that you have to do.